In neural engineering studies, pulse oximeters are used to measure heart rate or parasympathetic tone to rule out confounding factors of stimulation of nerves. But commercial pulse oximetry products normally filter heart rate to give a consistent number to the user, which introduces problems with motion artifact. It is possible to measure pulse oximetry non-invasively in anesthetized rodents, but not in awake moving rodents because of this filtering. My goal in this study was to design a pulse oximeter that could measure heart rate for conscious moving rodents by giving the raw, non-filtered signal. This way, you can visibly see what part of the signal is motion artifact and what is the raw, non-filtered heart rate signal, as shown in Figure 1. In this study, I tested different aspects of the design, such as sensor type, method of attachment to the rodent, and location of sensor. The final design used a 3D printed PLA clip, as shown in Figure 7, to hold the device on the rodents shown in Figure 2. It also used a pulsesensor.com pulse oximetry sensor, as well as a 3-volt cell battery, a Teensy LC microcontroller, and a radio frequency transceiver. This design would record the signal and then output it via radio frequencies at 433 megahertz to an Arduino Due that had a RF receiver and write that signal to the analog output to be viewable on an oscilloscope. Figure 3 and 4 show the specifics of the hardware and software of this final design. Moving to Figure 5, I tested the location of the sensor where I found the neck gave the most stable waveform. In Figure 6, I tested different modules and found that the pulse sensor also gave the most stable waveform. In Figure 8, I tested how long the device would stay on the rodent and found a mean of 57.4 seconds. In my future work, I hope to improve upon the 3D printed clip and add a spring to keep it clamped around the rodent to hopefully increase that time. I also hope to move my device from an Arduino Teensy platform to different microcontrollers to reduce bulkiness and weight of the device. Thank you so much for listening about my poster, and I'm eager to hear your thoughts and questions.